Hey everybody, today we're going to troubleshoot cold start issues on Bosch Jetronic fuel injection systems as performed on this Delorean's PRV engine. We see the injector connected right here at the auxiliary air pipe by the idle speed motor. It's very easy to troubleshoot on this particular motor, so let's get started. And as we can see, for our purposes, this engine is cold. I can put my hand on the manifold, I can put my hand on the valve covers. The water temperature is not 35°, it won't inhibit the cold start valve from operating. More specifically, the coolant temperature is less than 79.5 degrees, or in centigrade, we're looking at 26.2. Trying to start the engine will give you 10 minutes of this. Sometimes it'll buck, but it'll never run. In a pinch, I could depress the air metering plate slightly down under the air filter just to get a little gas in there to get it started. Or I could disconnect the gray cable on the control pressure regulator and plug it right in for a couple seconds just to give it a little bit of gas. But this isn't about how to get it started when it don't work. I want this to work properly. Before we begin, I just want to point out, I'm not a fan of digital meters for this specific application, so I'm going to use my Heathkit VTVM for this one. And I really don't want the fuel pump running for these tests, so I'm going to pull the fuse right here, fuse number 7, it's the top center fuse, and get that out of there before I continue. The Thermo time switch controls the cold start valve, and we're not just dealing with coolant temperature that disables this from functioning. That bimetal arm is also heated up from a heating element. So the longer I keep trying this, the more it heats up, the less of a chance we have of seeing that 12 volts. Too many attempts can invalidate my test, so I'm going to have to do this wisely on video. Here's the location of that Thermo time switch, here's that plug, and if I unplug it, we could see that it's keyed to going in one direction. Looks like a shape of an HDMI connector. If you manage to force it in backwards, you'll be getting yourself a new Thermo time switch. And it has 3 connections. One is for the heater, one is for the actual connection to the cold start valve, and the other one is the ground itself. I'm going to plug it back in now for testing. Now, while the engine's cranking, this is always getting 12 volts because it's switched on ground, not on the power. Left is ground and right is 12 volts. Maybe not 12 when the start is going, but close enough. So I'm going to connect to that positive constant side as well as ground off the water pump here, and we're going to see if we get that constant voltage while I hit the starter. And sure enough, we do. We're seeing about 10, just over 10 volts. Very good. This eliminates a lot of possibilities on that side of the circuit. Now I'll connect into that left side, which is the switched ground. Other side going to ground on my meter. A quick recap, this is a VTVM on full open, and here's a VTVM on fully shorted. I'm seeing about 2 ohms through my cables and everything, so that's just fine. I'm going to set this to the 50 ohm scale, so we're looking at everything is fully shorted. For our purposes anyway. Here we go. I measured exactly 1 second before the ground was cut out and it was deactivated. For 80 degrees outside, that seems appropriate. But we'll check the resistance off the switch leads anyway. Switching to the digital meter for better viewability, I put one side onto the water pump ground. Measuring each pin, I see one is that 2 ohms we saw before, so that's going to the switch power, and the other one is for the heater, and that's showing about 34 ohms, so that looks good as well. So from those readings, everything seems fine on the Thermo time switch. We'll compare this against a new Thermo time switch that I just picked up. Measuring against the shell to the first pin, and we're seeing the resistance to the cable, so that's a short, so that's good. And the other one we're seeing 61 ohms, which is interesting because that's almost double the resistance of the one currently in the car. Not saying that's a problem, but worth mentioning. So we're going to connect this new one right outside the car just to see how it functions. So I've just removed the cable from the old one and plugged it into the new one, but I'm going to have to provide a ground here because that's also a connection. And this looks a bit hokey, but I'm going to test it. So we're going to test this now. And we see the resistance through the cables. So this ground is good for our test. So through the injector grounding pin. Yeah, that didn't remain closed for any length of time. That did not activate the injector at all. Quickly switch back to the old Thermo time switch just to test my work. This time it ran for 1.05 seconds before shutting off. We'll install the new switch just to see if the coolant jacket has any effect on the switch operation. Using a 19mm spanner, I'll break the tension on the switch. And as I unscrew this, I'm going to make sure I have the other switch nearby because coolant's going to start to leak out. So I put my finger over the hole and making sure I have my metal washer on and never using any PTFE or Teflon tape, which will inhibit the ground. I screw it in, finger tight, all the way into full seat, and then snug it down. The old one was produced in the 11th week of 1981. 12 volt, 40 watts, assuming that's the switch side parameters. And designed to run up to 7.5 seconds at negative 20 degrees C, which isn't even close to what we're running, so 1 second seems plausible. 35C as per the documentation, the complete cutoff, or it doesn't function at all. And this appears to illustrate the maximum safe operating temperature for this switch, 150. How it was screwed in can change the direction of that plug position, so it's important to check. If you plug it in backwards, you're going to destroy it. So this one is actually 180 degrees out, so I made sure that as I plugged it in. Reconduct the test. No difference. It never turned on at all. Inversely, we're going to test the original switch outside the car. And it ran for 1.04 seconds, so testing the switch outside the car is valid. I'm going to stay with my old switch. I'm going to wash down everything that I just worked on, and my car will sound like a bunch of angry gerbils for a couple of minutes. We're going to move on to the cold start valve, as it wasn't the thermo time switch causing any issues, though we may have fixed or cleaned a bad connection along the way. I do want to make sure I have some resistance on this coil in here, so I'm checking it out, and I am seeing 185 ohms, so that tells me that things are looking good in here at least. I'll wrap a towel around the bottom of the valve because I know there's going to be a little bit of pressure on those banjo bolts, and when I loosen them, it's going to spray a little bit. No big deal. It's not a lot of gas. I'm using a 12 mil. Once I finish wiping up all that gas, I'll then unscrew that bolt up top, remembering that there's a washer on top and bottom of that hose, so I don't drop that washer, because that would suck. This mess does answer the question, of course, is it getting fuel? It is. And here's those two washers. Then I stick a paper towel in just a little bit to suck up all that gas that's stuck in the top of the valve. And I'll break tension on these two bolts. As I loosen them, I'm careful when I remove them because they too have a washer under each of them, and I don't want it to fall into the engine. Immediately as I remove it, I check this O-ring right here to make sure it's intact, a source of a vacuum leak. And where I live, I'll immediately cover this hole with tape so a family of mud daubers doesn't move in the next 5 minutes. Working with a cold start valve on the bench, we inspect it just quickly and we see that everything appears to be fine, no damage. We do want to make sure we know the polarity of these two connectors before we apply power so we don't break it, just in case it ain't broken. Reconnecting just for reference and pulling back on this shield, we could see red, white on the right, blue, black on the left. And looking at our diagram, we confirm that red, white makes its way up to our starter, so that's our hot side, and the other side will be our ground. I made this annotation on the connector. We're going to set up our DC power supply to around, 11 volts. We're not going to go full 12 volts because it doesn't generally see a full 12 volts. So that should be fine. Right about there, 11.5. I'll connect leads to both pins on the connector, and I'll remove this because we're going to use this as a momentary switch. DC power is now on. I'll switch over to current. And that immediately went to safety. My current is set way too low. Or there's a problem. We'll see. Louder spark, but still went to protect. We'll go higher, 1.5 amps. And now we're getting somewhere. Boy, does that make a spark. You see that? So I definitely don't want to test it out using this method in the car. That spark could definitely ignite gasoline if it's spraying out of that injector. As I click it and the residual gas comes out of the injector, you could hear an audible change in the tone of the clicking. Now we could hear it when it's empty. The solenoid's definitely working though. I'll take a moment just to clean things up a bit because here it's all filled with dirt and carbon or whatnot. I sprayed a little carb cleaner in here and then worked it through by pressing the solenoid, we could see it draining onto the paper towel. So it's not obstructed. How well the pattern is, I don't know, but it's not completely blocked, at least not anymore. I do this a couple more times. To the best extent I could see inside, everything here seems to be fine. The screen there, it's not obstructed with anything. So I added a length of hose to the end and then activated the solenoid and blew on the hose to push out the residual cleaner or whatnot that was in there. And we could see that there's definitely some sort of spray pattern for as much pressure as you could exert, blowing on it. I don't believe that this injector is a candidate for the ultrasonic cleaner. We'll test the pattern in the car. So we'll reinstall the injector temporarily. So I'm just going to put these two screws in loosely, and that's just to secure it so I could install that banjo bolt on the top. Making sure I have both washers for the installation and I don't drop any during the installation, especially that bottom one. Put that bolt on and start it with my fingers till it's tightened, and then I'm going to snug it down ever so gently. The two bolts I put in should stop it from rotating while I snug this bolt down. Now I can remove those two bolts. I'll remove the injector and lay it off to the side. If you're doing this step, you should be using a large enclosed container for this. I'm not, but I need this set up for the video. Messing up is a good way to get yourself killed. You do so at your own risk. So what I'm going to do is pull my RPM relay and plug in this bypass wire I keep in the ashtray to pressurize my fuel system. So I'll leave this in, and I can hear the fuel pump go for a bit, and then I'll unplug it, and then I'll disconnect the battery, reducing my chance of any unwanted sparks. This time I'll be running off of the switch of the power supply, which has a spark arrestor inside. I'll lift up the injector so we can see, and there we go, a mist of gasoline, which is very dangerous, doing this with a lot of fresh air and ventilation, where it dissipates in the air. Again, and we can see a nice cloud of gasoline. We definitely wouldn't want that to ignite. I'll do a couple of quick close-ups, and then I'll let this place ventilate. Remember, atomized gas is dangerous. The battery is not connected on this car. The pattern looks great. Our test is completed. We could disassemble everything now. We'll get this measuring cup out of the way and just drop the cold start valve right into position. Reconnect our bolts. Snug everything back down. And reconnect our cable. Everything's back together. One point of failure is this piece of plastic that secures the connector to the Thermo time switch. It becomes brittle over time and doesn't hold the connector together, allowing it to fall out. I've just replaced this with a small piece of heat shrink, fastening both connectors together, holding it by the barbs. Plug in my RPM relay as well as fuse number 7, and we're ready to test it out. Same criteria, stone cold engine, just as before. We're going to go and try and start it up and see how it runs now. Started up with no problem. Everything's running good. The repairs were not expensive and the troubleshooting was easy. I just check around this banjo bolt on the cold start valve and make sure it's not leaking since that seal was broken and retightened. Everything looks okay. And that concludes this video on the cold start valve and associated circuit and repair. I hope you found this video enjoyable, entertaining, and informative. Do me a favor, hit that like button down below. Helps me out a lot when you do. And hit that subscribe button for more videos like this when they come out. Again, I hope you enjoyed this video. Thanks for watching.
Thanks for watching. Would you like to reply?